Hello everyone, welcome to Unacademy, India's largest online learning platform. Very good evening to all of you. Yes, I know today is a being Sunday. Everyone will be occupied with many other things, but I'm happy that you are here to listen to my class. Very happy about your presence. Very good evening to all of you. So today is the semiconductor physics class 4 we will be discussing, and let's move on. So myself, Shravan Kumar, many of you know it, but for those who are coming for the first time, so myself, Shravan Kumar, I have master's degree from JNTUH in VLSI system design. Raviteja, good evening. Good evening, Raviteja. And I have 10 plus years of teaching experience, and I can handle subjects like EDC, analog electronics, digital electronics, and EMFT. And I have a special code for all you guys, that is SVS10 to get 10% discount on plus subscription. Okay. So what do you mean by plus subscription is? A plus subscription will give you Monica, good evening, Monica, good evening. Give you access to the live classes. You can attend all the crash courses. You can write the weekly tests. So time and again I'm mentioning, writing tests is a very important for a GATE student, GATE preparation student. Then only we will know your progress, how much you are progressing. So this writing weekly test is very important, and you will be having something called doubt solving sessions. Every 4th hour is going to be a doubt solving session, and sessions will be in English and Hindi. And you have something called rank improvement batch. This is to improve your rank if you are under below 10,000 or 5,000, 6,000. If you want to get below 100, below 10, so this will help you a lot. So this is called plus subscription, and we have something called iconic subscription. Along with the plus subscription benefits, the iconic subscription benefits will be, you will be given a personal coach, you will be having a study planner, you will be given a study booster sessions, a personalized test analysis will be conducted, which is in-depth analysis will be given for all of you after the examination, and you will be having a preparatory study material which will help you a lot in your preparation. Okay, then the fee structure for plus subscription for 12 months is going to be 27,225 rupees. For 18 months, it is 34,650 rupees. For 24 months, it is 39,600 rupees. For iconic subscription for 12 months is going to be 45,225 rupees. For SVS10 is the code which you have to use. For 24 months, it is going to be 66,600 rupees. That is SVS10 is going to be the code which you have to use to get 10% discount on it. So soon this 10% discount is going to be decreased to 5%. So please hurry up in getting this offer. Utilize this opportunity very quickly. Okay. Yeah. So how you get, sir? Simply download Unacademy app, install it, and then you should choose your goal, that is GATE and ESE. Then you will be given a plus subscription. Click on a plus subscription, get subscription. Then you have to choose how many months you have to choose. So either 12 months or 24 months. But don't forget to type this SVS10 code to get 10% discount. Then you will be proceed to payment. You can do the payment using debit card, credit card, EMIs, UPS, wallets, net banking, whatever you want. Whatever you want, you can do it. Whatever you want, you can do it. Okay. Balaji, good evening. And now here comes. So what were the most important takeaway points from yesterday's class? Again, the story starts here. Now I want answers for this question. What were the most takeaway points from yesterday's class? Now let us see who will answer this question. Okay, before going to do that, I just wanted to check who answered my questions very clearly in yesterday's class. In yesterday's class, Raviteja Anne was there, Mr. Achiever was there, Monica was there, Balaji Guru was there, J442 was there. All these students answered my questions immediately. They may be about the previous class questions, or they may be the questions which I asked immediately while we are talking about some concepts. So these were the students who answered my all questions. So let us see who will answer today. So what were the key takeaway points from yesterday's class? I'll wait for another 10 to 15 seconds to get response from you guys. So these are the students who answered my questions yesterday. I think these students are also already there. Raiteja is there, Monica is there, Balaji is there. I'm still waiting for Mr. Achiever, J442, and many other students are also answered. I'm waiting for today's answers. Mass of an atom is concentrated in the nucleus. I think that we discussed first class, not yesterday's takeaway points. What were the topic? Yeah, Monica, you are right. We discussed about Bohr's atomic model. So what were the takeaway points of Bohr's atomic model? What were the three important takeaway points from Bohr's atomic model? I think today also Raviteja is answering and Monica is answering. Good that we discussed. Balaji also answered. Yeah, Guru Balaji is also here. Correct. We discussed those points. But yes, we discussed about Bohr's model. Can somebody tell me what are the points of Bohr's model? If somebody can type what are the key takeaway points from Bohr's model? Bohr's model. Based on this Bohr's model, today's class will continue. Based on Bohr's atomic model conclusions, today's class is very important. Today we will be discussing about atomic energy levels. Okay, I'll do one thing. I'll go back and do some revision. I think we discussed about who is Rutherford and who is Bohr yesterday. Yeah. And then Bohr's atomic model. You can see the Bohr's atomic model says atom can possess only certain discrete energies, while in states corresponding to these discrete energies, the electron doesn't emit. So atom always revolves around in stationary orbits, and it will not emit the radiation when they are rotating in this stationary orbit. That was the first takeaway point. First takeaway points. And second takeaway point, what he says here, whenever it is moving from one energy state to another energy states, it radiates energy. The first case, it will not radiate when it is in the stationary orbit. The second case, whenever it is moving from one stationary orbit to the other stationary orbit, it radiates energy. It radiates energy. Okay, it radiates energy, and we have seen this a formula for wavelength. Wavelength we have seen lambda is equal to 1.2 by E2 minus C1 micrometers, and then in angstroms also we have discussed. And then I think we have solved some problem also. This was asked in 2014, and this is the important point. The stationary wave, a stationary state is determined by the condition that the angular momentum is an integral multiple of h by 2 pi. We have discussed this. This is also a very important point which we have discussed. And then we have concluded that the energy of an nth orbit, energy of an nth orbit is given by minus 13.6 by n square in electron volts. Electron volts. So this we have discussed yesterday. A very important takeaway point is here. The energy of an electron in the nth orbit will be determined by an expression En is equal to minus 13.6 by n square electron volts. This is the very important takeaway point which we have discussed. This is the very important takeaway point which we have discussed in the last class. Now, I think that was the previous case, and we have solved some problem. I think this is the answer which I got is correct. So if somebody got 5780, that's okay, or somebody got 5755 also, I think. This is also right answer. 5755 is also right answer. I think I don't need to answer this. Yesterday somebody has got some other answer. Yeah, now I got this answer 5755. Hope this answer is correct for all of you. Or 5755.55 something we got. Hope this question this answer is right. 5755.5. The 5756 is an answer. Okay. Yeah, I think this is the last class we discussed. That's it. And let's move to today's class. So these are the people who yeah, Raviteja, yeah, very good, Raviteja. So moving on to today's class. So before going to today's class, I just wanted to say this very important thing. Remember, winners do not do different things. They do things differently. Still, they'll study the textbooks which you are studying. Those are the achievers of life who achieved very great things in their life are not doing anything different. They are doing the same thing. They are doing the same books. They are doing the same things, but they are doing it in a different way. They accept their problems. They realize their problems. They understand their mistakes. They correct them and they move forward. Hope you will be the winners of tomorrow. Accept where you are not good. Note down where you are not strong and try to focus on them and be a winner of tomorrow. Achiever, good evening, Achiever. Welcome. So my humble request is remember this quote: winners do not do different things. They do things differently. That's it. Hope tomorrow you'll be the great winners of your life. I'm not restricting my wish just for this GATE preparation or the IS preparation. I want you to win in life, not just in the exam. Exam is just part of your life. Exam is a part of your life. Okay, so think beyond this examination. Think beyond this examination. Hope you will be the great. You'll see the great success in your life, right? Thank you. We'll move on. Now here comes, this is the most takeaway point which I was mentioning. So the energy Wn is going to be minus m into e power 4 by 8 h square epsilon naught square n square. I think we have concluded that this can be written as En. The energy N is going to be minus 13.6 by n square electron volts. Minus 13.6 by n square electron volts. Okay. My 13.6 by n square electron volts. Now we'll try to understand what does it mean. So what is the energy level for n is equal to 1? For n is equal to 1, what will be the energy level En, sir? En is going to be, if you substitute it here, is going to be simply minus 13.6. What does it mean? What does it mean? It means that just give me a second. Just give me a second, sir. Just give me a second. Just give me a second. I'm just trying to find out different energy levels of different electrons. Just wait a second. I would have done this earlier, but due to some busy schedule, I did not do this. Assume that this white indicates the nucleus. Yeah, Shiva, you're right. Shiva, you're right. Harika, you're right. Yeah, I missed your names. I missed in your names in this today's presentation. I would have added the Harika and Shiva here. I would have added the names of Harika and Shiva here. Okay, I'll remember your names also, Harika and Shiva. That's good, right? Now, assume that this is going to be the nucleus. This is going to be the nucleus. This is going to be the nucleus, and assume that this is going to be n is equal to 1. This is going to be n is equal to 1. N is equal to 2. Yeah, this is not so bright. Yeah, what should I do? This is going to be n is equal to 1. N is equal to 2. But I think this will not work out with this n is equal to 3. Right? And then you will be having n is equal to 4. And then you will be having n is equal to 5. Like this. Like this. Oh, achiever is J in 442. Oh, both of you are saying? Okay. Okay, Mr. Achiever. I noted. You are also noted. Yeah. Now see, for this, try to understand what I'm saying. For n is equal to 1, we got that if the first orbit, if the electron is in the first orbit, its energy is going to be minus 13.6 electron volts. Minus 13.6 electron volts. If n is equal to 2, so what is energy, sir? En is going to be how much? It means that minus 13.6 by 4. How much is going to be, sir? Almost 4 means you will get, I think this is going to be minus 3.4 for 16 and then 1. Approximately you will get minus 3.41 electron volts is what you get. Minus 3.41 electron volts is what you will get. To remove an electron from the first shell, we required minus 13.6 electron volts. That we'll discuss. Very good point you proposed, Mr. Shiva. That energy, we have given some name to it. I'll reveal it in another 10 minutes, another 5 to 10 minutes. After once I discuss these things, I'll tell you. Yeah, you're right, Rateja, you're right. Then, and for n is equal to 3, the electron volt En energy of the electron is going to be minus 13.6 by 9. 13.6 by 9 minus around this will be minus 1.3 electron volts. Minus 1.53 electron volts. If n is equal to 4 and 5, if n is equal to 4, that is going to be now the electron En is going to be now minus 13.6 by 4 is what we'll get, sir. How much you're going to get? So how much I don't know how much you are going to get. I don't know. This will be 4 square 16. 4 square 16. Yeah, correct. Harika, you're right. Achiever, you're right. Then what is going to be n is equal to 4? 4 square minus 1.53. I think we got already minus 1.53. Yeah, you're right. For n is equal to 4. I'm happy that you're all replying. Seriously, I'm very, very happy about your response. That's going to be 0.87. And then for n is equal to 5, En is equal to minus 13.6 by 25. That is going to be, I think, we'll get minus 0.56 electron volts. So similarly, this will continue. This will continue. Singaridi, I'll answer your question. Don't worry, I'll answer your question. Don't worry, I'll answer your question. Now, see, I'll just translate this circular diagram into a different energy diagram. I'll try to do that so that you'll understand what I'm trying to explain it very clearly. Right? So now I'll try to do it here so that you guys will understand what I'm trying to say. What I'm trying to say. This is called energy level diagram. This is called energy level diagram. Hope you are able to see what I'm writing here. Yeah, you are right. You are right. Energy level diagram, I'm trying to do it. Now, this is going to be n is equal to 1. This is going to be n is equal to 2. For n is equal to 3. For n is equal to 4. For n is equal to 5. And just now we have written, I think you have told me this is going to be minus 13.6. This is going to be minus 3.41. 3.41. This is going to be minus 1.53. Minus 1.53 is going to be minus 0.87, minus 0.56, 0.56. And this lowest energy level is called normal energy level, normal state, we call it as normal state. Now you understand here. These other states, we call them as a radiated or excited energy levels. Radiated or excited energy levels. See, if I want to get what will be the value of 0 to get 0 here, so what is required, sir? For what value of n this will become 0, sir? This will become 0 for n is equal to infinite. En becomes 0. En becomes 0. Now, in the other way around, you should think. Now, I'll try to explain you what do we mean by this n is equal to 0. This n is equal to infinity. N is equal to infinity. Now just think about it. As Shiva was clearly mentioning, same thing is that, right? So if you look at here, if you want to detach an electron, let's say electron is moving here, so to detach this electron, see, for n is equal to 3, so for n is equal to 3, how much is energy, sir? It's going to be minus 1.53 electron volts. If you apply an external energy of minus 1.3 electron volts, you can detach this electron from the nucleus. You can detach. So as Shiva was clearly mentioned, this is the same. The energy required by an external voltage which will detach the electron from its stationary orbit is called ionization potential. What we call it as, sir? We call it as ionization potential. Ionization potential. This is very important, sir. Ionization potential is very important statement which I have maintaining. So what do you mean by ionization potential? Yes, Guru, you are right. Yes, Guru, you are right. What do you mean by ionization potential? The energy required by the electron to move completely out of the field. To move completely out of the field is nothing but an ionization potential. An ionization potential. Let's say if the electron is in the second orbit, if the electron is in the second orbit, it requires a minimum amount of minus 3.4 electron volts. It requires 3.4 electron volts to detach itself from the nucleus. So this is how we need to understand. You need to understand in other way around. So these are the different energy levels. The different energy levels. These are different energy levels, right? To the external voltage which is required to detach an electron uh, from the atom is called from the nucleus is called ionization potential. Ionization potential, right? Did you understand the point? What do you mean by ionization potential? Is the point clear for everybody? Is the point clear for everybody? Please let me know. Please answer my question. Are you able to understand? Yes or no? Yes. Yes. Okay. Okay then. Okay then. Now this level is called ionization level. As Shiva was rightly mentioning, as Shiva was Guru Balaji, I'll simply tell you here. Okay, okay, no problem. I'll explain it. I'll explain it once again. Balaji, see the electron which is revolving in orbit number 1 is having how much energy, sir? It is having an energy of 13.6 electron volts. And the electron which is revolving in the second orbit has an energy of minus 3.41 electron volts. The electron which is revolving in orbit number 3 has minus 1.53 electron volts. See, whenever an external voltage is supplied, external potential is supplied, then let's say I'll try to do it here. Let's say some electron is here. Some electron is in the normal state. I'm saying this is going to be normal state. So to move this electron from this normal state to the ionization state, you require this amount of energy. This amount of external voltage is required. This amount of external energy is required to move the electron from this normal state to ionization state. What do you mean by ionization state, sir? It will go out of this. It will detach itself from the nucleus. Hope you're understanding. Hope you're understanding this point. Hope you're understanding this point. Hope you're understanding this point. Okay, so if the electron is in the second orbit, if the electron is in the second orbit, so it requires 3.41 minus 3.41 electron volts energy to move itself to detach itself from the nucleus. See, we have discussed very clearly. We have discussed Shiva. We discussed in the previous class that we have clearly discussed in the previous class that the energy of an electron is negative. The energy of electron is negative, where the energy of proton is a positive. Okay, energy of electron is proton is positive, and generally we call nucleus is a positive energy is having, and electron is having negative energy. I don't know why you are asking again. Did you miss my class yesterday? Shiva Singh. Okay, so now the energy required by the electron to detach itself from the nucleus is called ionization potential. Now, see, one important thing you should remember is, now just now I told you that an electron will detach from the nucleus and it will go to the higher energy levels. I would use a word higher energy level, higher energy level, higher energy level. Okay, the electron which is moving from lower energy level to higher energy level will not stay there. Will not stay there. It has to come back to its lower energy levels. It has to come back to its lower energy levels. See, it gains some. See, now I'll tell you one more thing important here. Now I'll take this opportunity to tell you again here. Okay, no issue, Shiva. No issue, Shiva. Remember, no issue, Shiva. Remember, energy of electron is negative. Energy of electron is negative, right? It's going to be n is equal to 1, n is equal to 2, n is equal to 3. I don't want to mention everything here. N is equal to 4, n is equal to 5, and you will have another energy level that is the infinite. I generally call is equal to n is equal to infinity. Infinite will call, right? Right. Assume that an electron is moving from n is equal to 1 to n is equal to 5 or n is equal to infinity, right? The electron which is moving from the lower energy level to the higher energy level will not sustain there itself. After its lifetime, it will fall back to its lower energy levels. It will fall back to its lower energy levels. When it is falling back to lower energy levels, it may come back directly in one jump to the lower energy level, or it may jump multiple, it may do some multiple jumps also. Remember, the electron may jump directly, or it may do some multiple jumps also. It may do whatever, it depending on energy, how much it is losing, right? So as I told you, the electron may not jump directly from n is equal to 1 to n is equal to infinity. It may simply jump to this third level. Whenever it gains some amount of energy, sir, this concept looks bit complicated, but just understand simple concept. This is very simple concept. Don't think it is difficult. See, now what I told you, electron is in the n is equal to 1 orbit. N is equal to 1 orbit. It means it is in the normal state. When it is in the normal state, I am trying to apply some external energy. When I'm trying to apply some external energy, it will jump from lower than energy level to higher energy level, because when it is moving from nucleus, when it is moving away from the nucleus, we have concluded that the energy of electron will increase. Or when electron is coming closer to the nucleus, its energy decreases. That is the takeaway point from class 1, class 2, class 3 points, right? So depending on that, now remember, electron may jump from lower energy level to higher energy level directly, or it may jump to the n is equal to 1 to n is equal to 3. It depends on its own. How much extra energy it is getting? How much extra energy? See, to jump, let's say now this is going to be how much, sir? Minus 13.6. How much energy is this? Minus 3 point, I think 3.41. This is going to be minus 1.53. Right? If the electron is jumping from minus 13.6 to minus 1.53, let's say, as you was rightly mentioning, if the external voltage, external energy which an electron is getting from the outside is minus 13.6, then it will jump from n is equal to 2 to n is equal to infinity. I repeat it again. If the external energy which this electron which is revolving in the n is equal to 1 orbit is minus 13.6 electron volts, then it will jump from lower energy level to the infinite energy level. Otherwise, let's say it is having only, let's say the energy which is it gained is only 12 electron volts. If it is 12 electron volts, it will not jump from n is equal to 1 energy level to the n is equal to infinity, but it will go from n is equal to 1 to n is equal to 3. Hope you are getting my point. So the electron will jump from lower energy level of n is equal to 1 to higher energy level of n is equal to 3, depending on the how much energy it is getting. And whenever it is coming back, it will not, it may come back directly from higher energy level to lower energy level, or it may do some jumps, different jumps, or it can stay here. So now when it is jumping, from higher energy level to lower energy level, now it will radiate some energy. It will radiate some energy. This is radiating energy. Radiate energy. When it is moving from lower energy level to higher energy level, it has to absorb the energy. When it is moving from higher energy level to lower energy level, it has to radiate energy. Two things are happening, right? One is gaining energy, one is releasing energy. So whenever it is moving from lower energy level to higher energy level, it has to absorb the energy. When it is moving from higher energy level to lower energy level, it has to radiate energy. And this radiated energy is called as photon. It is called photon. So this is, I think, which was mentioning about Raviteja. Raviteja, I was talking about this in the first class. There is something called photon, not proton. Proton is different and photon is different. Now, the energy which is radiated by the electron when it is moving from higher energy level to lower energy level is nothing but a photon. Photon. Okay, this point you need to remember. This point you need to remember, right? So if you go back and see in this previous case, so generally what happens, I'll tell you. I'll tell you these ranges. I think probably you might not be knowing. You might not be knowing this. If the energy, if the electron is jumping from this energy level to this energy level, this energy level to this energy level, we call this as UV radiation. This is called UV radiation. If this is moving from second energy level to the third energy level and the second energy level to the third energy level, we call it as visible excitation. We call it as visible excitation. And then if it's moving from n is equal to 3 to n is equal to 4 and n is equal to 4 to n is equal to 5, we call this as a, so this is very important, sir. This is very important. So you may not know this. You may not know this. Now I'm trying to explain here. Again, remember this is UV radiation. This is UV radiation. This is UV excitation. I call this as excitation. You will call excitation. UV excitation. This is called UV excitation. If it is moving from n is equal to 2 to n is equal to 3 or n is equal to 4, then this is visible excitation. Visible excitation. And this is IR, infrared. This is infrared excitation. Hope you're getting the point. Hope you're getting my point. Hope you're getting my point. So this is whenever electron is moving from n is equal to 1 to energy level to n is equal to 2 or n is equal to 3, then that is called UV excitation. It is moving from second energy level. So it means, so he's talking about this. If the electron is moving from lowest energy level to the next two energy levels, it is called, it is exchanging between these two energy levels. Whenever this is exchanging between these two energy levels, it is what radiation? So it is excitation is called UV excitation, ultraviolet excitation. If it is moving from second energy level to third and fourth, or fourth to third, and whatever is happening, that is called visible excitation. If the electron which is there in the third orbit is moving to the next levels, then that is called infrared excitation. Infrared excitation. This is what we're talking about, right? So now this is called radiated energy, and this is called photon. The photon, how you measure the photon? Photon is equal to h into f. We already know what is h. What is h, sir? H is the Planck's constant. H is Planck's constant, and f is the frequency. H is the frequency. H is the frequency. This you should know, right? So this is actually, this is nothing but energy radiated in the form of light. Actually, light energy will be radiated. Shiva, we'll talk about it later. We'll talk about it later, not now. Surely, whenever the point comes to our discussion, we'll discuss it in detail. We'll discuss it in detail. You need not worry. Okay, Shiva? You need not worry. Okay. So this is what a radiated energy. So now what we need to remember is a photon, the energy which is radiated by an electron when it is moving from higher energy level to lower energy level, it will radiate energy, and that is called a photon, and a photon is represented by h into f, h into f, h into f. Hope you are getting the point. Hope you are getting the point. Sir, initial classes of EDC are very important, and they are more of theory. They are more of theory, but still I am trying to include some questions into it. I'm still trying to include some question to it so that I'll make it interesting. So that I'll make it interesting. Okay. Hope you're getting the points. Okay. Let's move on. Now, this is one more very important topic of the electronic structure of an element. Right. So far, we have discussed what is an electron, it is staying, how many electrons, all these things. Now we'll talk about something called electronic structure of elements. We'll go to the next level. Just a second. See, so far what we have discussed, sir, if you look at our previous journey, we started our discussion is about electron, and then we come to know that there is something called matter. From matter, there is something called molecule. From molecule, we have discussed that the atom. From the atom, we concluded that there are electron, proton, and neutron. Electron, proton, and neutron. We don't have any issue with proton and neutron because they stay inside the nucleus. Inside the nucleus. But electron is such an element. Electron is such an element in an atom which is not staying in one place. Which is not staying in one place. It is revolving around the nucleus. It is revolving around the nucleus in different way. If you go back and see, if you want me to show this, I just wanted to show it again. So this is a electron which generally revolving around the nucleus. This is how electron is revolving around the nucleus. Now we should find out where it is now exactly. How to locate an electron in an atom. How to locate an electron in an atom. This is the question. This is a very important question. For that, we need 4 quantum numbers. We need 4 quantum numbers. They are considered as N, L, ML, and MS. Sir, it is simple. It is a very simple concept. See how to identify. It is just like giving an address to you. It is just like giving an address to an individual. Let's say, example, somebody who is staying in Chennai. How to identify, how to give an address to a guy who is staying in Chennai or Delhi or Hyderabad. So there will be given some door number, there will be given some flat number, or there will be given some area number, there will be given some pin code. Yes or no? If you look at the pin code, by looking at the pin code, you can identify. By looking at the pin code, you can identify in which state he is, in which area he is living, and in which town he is living. And from the door number, you can find out in which area is living. The same concept is here, something called electronic structure of an element. Electronic structure of an element defines where an electron is. It is trying to locate an electron. The electronic structure is simply defines the position of electron, where it is, how it is. And for that, we need 4 quantum numbers. We need 4 quantum numbers. What are they, sir? We call them N, L, ML, and MS. Okay. Please understand what is this N, L, ML, and MS. They are the 4 quantum numbers. They are the very important 4 quantum numbers which are required to locate an electron. to locate an electron. Depending on that electronic configuration, we will decide what is energy level also. What is energy level also. Then we'll define what is valency electron, what is core electron, what is conduction electron. All these concepts, why I'm trying to do, sir, I'm trying to give a foundation for a concept called semiconductor. Because entire electronic device concept depends on the concept of semiconductor. If you want to understand what is semiconductor, how it behaves, what happens inside in semiconductor, how electron behaves, for all those things, this is very important. Okay. Is it okay for all of you? Say yes, no, yaar. Why are you so idle? Just type something, yes, no, maybe. Balaji responded, Achiever responded. Good that you are just at least you are focusing on this. Raviteja responded. I don't know where is Shiva, Monica, Harika, Shiva, Monica. Where are you now? Okay, that's good that you are listening. Okay, now we will see how to identify an electron, right? According to Pauli's exclusion principle, states that no two electrons in an electronic system can achieve can have same set of quantum numbers. Obviously, if any two electrons in an electronic system have same kind of quantum numbers, how will you differentiate them? You will not differentiate them. It is just like a thumb impression of a human being. It is just like a thumb impression of human being. So no two human beings in the world, no two human beings in the world has same kind of thumb impression. Same kind of thumb impression. Similarly, no two electrons. This Pauli, this scientist by name Pauli, says that no two electrons in an electronic system can have same set of quantum numbers n, l, ml, and ms. So what these will define? What is n? What is l? What is ml? What is ms? Right? So if you look at this n defines in which shell it is, electronic shell, in which shell it is, where L defines what is the subshell of the atom, what is subshell of an electron, subshell of an electron, and Ml defines its energy level, and then Ms defines its spin. Yeah, Monica also responded very good. So these shell, subshell, energy level, and spin, they are the very important four quantum numbers which will define the position of an electron, which will define the not just ms achiever, not just ms, everything, not just ms, not just ms, everything will define, everything plays a major role. Everything will have this their own difference. Of course, at the end, this ms will define. At the end, the final number, which will define which type of, depending on the spin of an electron, which is in the positive direction, or upward direction, or lower direction. So that will be defined by the spin of an electron. You can call energy, angular momentum, magnetic moment, and the spin. This can also be correct. Raviteja, you are also right. So we will define the energy level, the shell in which it is having, how much is the angular momentum it has, how much is the magnetic momentum it has, and the spin of electron. Yeah, we can map according to our own discussions. We can map according to our own discussions. You are right. You are right, Teja. You can also map. So that in detailed discussion we need to do it. In detailed discussion we need to do it, right? So 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 according to Pauli's exclusion principle, the states that principle states that no two electrons in electron system can achieve same set of quantum numbers. So now what is electronic shell? What's an electronic shell? Sir, will actually, in my point of view, we should focus more on this in detail continuous class, right? So definitely, I think at least I need 30 to 40 minutes to discuss about this electronic structure of an electron, right? So we will not leave this here. So just but I'll show you one diagram to tell you how the electron looks like. So if you look at this diagram, I'll give you a hint. Tomorrow I'll discuss in detail about this. Tomorrow I'll discuss in detail about this energy level. You can see here for n is equal to 1 we have S, for n is equal to 2 we have SP, for n is equal to 3 we have SPD, for n is equal to 4 SPDF. Depending on the value of n, so you can see here it is a shell. It is a shell. You can see this red in color, this is green in color, this blue in color, this orange in color. So each color differentiates the shell in which the electron is present. The shell in which the electron is present. And this levels you can see there has SP. SP are two different subshells. The two different subshells of an electron. The two different subshells of an electron is going to be this two levels. These two levels. And you can in this case also you can see the 3. In this case you can see the 4. Right? SPDF. So each of them is showing shells, and then it's going to be subshells. And then in detail also we will discuss. In detail also we will discuss how the electron will be. How to define the electron which is there in this. So this is D, SPD. So D, let's say the electron is here. So how will you define this electron configuration? How can you decide 1s2, 2s2, 2p6, the 3s2, 3p6, 4d1. This is how you will define. This is how you will define. I'll make you to understand. I'll make you to understand how the electronic configuration has to be written for any given electron which is present in some shell. So this is what you have to do. So the electron which is there here means it has filled states of all these things. It means it has 1s2, it has the 2s2, 2p6, 3s2, 3p6, 3d10. Actually, this is also not. I think. Still, I need to do this. This is also still. So all these things also filled, right? This 3d10 also filled. 3d10 also filled. Then 4s2, 4p6, then 4d1. So this is the electronic configuration of an electron which is present here. So if the electron is present here, we can write simply it's going to be 1s2, 2s2, 2p6, 3s2, 3p6, 3d1. So I will ensure that you will understand this in tomorrow's class. So don't miss tomorrow's class. My humble suggestion is tomorrow's class is very important. We will discuss about how to identify an electron basing on this electronic structure. Electronic structure. How to identify an electron, in which subshell it is, in which spin it is having, in which angular momentum it has. So this plays a major role in tomorrow's class, right? Just going back to what we have discussed today. To summarize, simply, so we started our discussion with atomic energy levels. So for different atomic energy levels, we understood that how it has to be defined. So we have discussed what is ionization potential. Also, we have discussed what is ionization potential and how the energy levels will be there. This energy level diagram we have discussed. We have discussed energy level diagram, which is very important to understand. After that, we have seen what do you mean by a photon. We just concluded that an electron which has absorbed energy and moved to the higher energy levels may come back directly to the lower energy levels, or may not come back, or it can do multiple jumps and come to the original position. So while it is coming back to the original positions, it has to radiate some energy, and this radiation energy will be in the form of light, and we call it as a photon. We call it as photon. We call it as a photon. Okay. Once we call this as a photon, and then we started discussing about electronic structure of an element. And we have told that there are the 4 quantum numbers which are required to locate an electron, to define the position of electron. Those are N, L, ML, and MS. So I told them as simply shell, subshell, energy level, and spin. And somebody told it as a energy, angular momentum, magnetic momentum, and spin. We will definitely conclude on that in tomorrow's class, right? So don't miss tomorrow's class. We will have a clear discussion about this in tomorrow's class. Okay, and we'll see how many number of electrons can be filled, how many maximum number of electrons can be filled in subshell. It is a shell and subshell. What do you mean shell, subshell, and how many maximum electrons can be filled? This also we'll discuss in detail. This also we'll discuss in detail in tomorrow's class. You can see this complete discussion in tomorrow's class. So we will see what is the electronic structure of this carbon, silicon, germanium, tin, and how we have told all these things, how to identify the location of an electron. Okay. Yeah. So that is all. What about tomorrow's class? Don't miss my tomorrow's class. Don't miss my tomorrow's class. It's very important. We have something called plus subscription. The plus subscription is nothing but you can attend all the live classes. You can attend the crash courses. You can write the weekly tests. Weekly tests are very important. Don't miss the weekly test. We'll be having doubt solving sessions. Every 4th hour is going to be a doubt solving session. Sessions will be in English and Hindi. Sessions will be English and Hindi. And we have something called rank improvement batch, which is also very important for plus subscription. And we'll be having icon subscription. The extra benefits of an icon subscription is we'll be given a personal coach, we'll be having study planner, we'll be having study boost sessions, we'll be given a personal in-depth analysis after the test. This is very important. This plays a major role in improving your knowledge. Okay. Then you will be given a preparatory study material. Okay. And the fee structure for 12 months is going to be 27,25 rupees for plus subscription. For 18 months, it is 34,650 rupees. For 24 months, it is 13,600 rupees. And for iconic subscription for 12 months, it is going to be 45,225 rupees. For 24 months, it is 66,600 rupees. 66,600 rupees. So I'll post my class notes in Unacademy GATE English Telegram channel. So please subscribe for this Telegram channel. Hope you are getting already all these notifications. So how many of you are downloading these Telegram notes? How many are seeing? How many of you are seeing? Okay. So I'm teaching on Unacademy GATE English. I'm teaching on Unacademy GATE English EDC subject. And we have extra YouTube channels. Also, we have Creatix GATE channel, and we have Unacademy GATE Mechanical Instrumentation. This is going to be Production Engineering and Engineering Sciences. We have another channel. We have different channel for Unacademy GATE Civil and Chemical Engineering. We have a channel for Unacademy Computer Science Engineering. Unacademy Computer Science Engineering. Thank you, Ravteja. Thank you. Thank you, Achiva. Thank you. Unacademy GATE questions. Unacademy GATE questions. A separate GATE questions channel is defined for you, right? And we have something called electrical junction. Electrical junction. We have something called Monica. Thank you, Monica. Thank you. We'll catch up tomorrow. Don't miss my class tomorrow. So the important thing is, please like the class, share the class, subscribe the channel, hit the bell icon. Let others also learn more. Let others also learn more. Please do share. Please do share and like the channel so that you will get more views. We are struggling hard to satisfy you. We are not charging anything, even single rupee is not charged from you. We are simply transferring our knowledge for free of cost. So just one like and one share is important for us. Unacademy is expecting that, only simple that thing. Nothing is expected from you. So please do share the class. Okay, thank you. We'll catch up in next class. We'll catch up in tomorrow.